Welcome to this vodcast that's going to look at applying similar figures. Now that we know what similar figures are, how can we use what we know about those to solve some problems? So, first thing I need you to do is go to page 100 in your workbook, page 100, and we're going to do 3 questions together. Let's start with question number 1. Two similar figures have a ratio of 3 to 5. If one side of the smaller figure is 9 centimeters, how long is the corresponding side of the larger figure? Okay, when we're working with similar figures, we're always going to use proportions. And so far, we've been talking about using big over small. Okay? Now, the hardest part is setting up the ratio. Once you've got it set up, I know y'all can do the math to solve this. So let's fill in some information we know. These two similar figures have a ratio of 3 to 5. You need to think very carefully about how you fill this in. Would the 3 go up top or on the bottom? Well, since we set ours up as big over small, we're actually going to have to write our ratio as 5 over 3, the bigger number over the smaller number, okay? If instead you had done your ratio as small over big, like you flipped it upside down, then you could do 3 over 5. Okay, next thing is we've got to fill in another piece of information. One side of the smaller figure is 9. So where does that 9 go in our proportion? Well, it was in the smaller figure, so it's going to go down here with small. And what are we trying to find? How long is the corresponding? Corresponding just means matching, let's say, matching side of the larger figure. That's what we're going to call x. Okay? Once we've got this set up, we know the math. And I'm going to move across my booklet here to my workspace and recopy my proportion. 5 over 3 equals x over 9. Ask yourself, how do you solve for x? We multiply 5 times 9, and then we divide by that last thing, divide by 3. So let's go ahead and work it out. You work yours out, I'll work mine out, we'll see what we get. 45 divided by 3 is 15. Get 15. Okay, let's go see if that's an answer choice. Going back to number 1, how long is that larger side? Sure enough, it's 15 centimeters. Again, the math part of this is easy when we multiply and divide. It's setting it up that's tricky. Let's try number 2. Given the diagram below, how long is the hypotenuse of the triangle DAN? Well, for starters, let's find what we're looking for, hypotenuse of DAN. And the hypotenuse we know is always across from the 90. So hypotenuse of DAN is going to be this big thing here, and we're going to go ahead and call that x. And we'll see that we don't know what that is yet, but we could set up a proportion to help us find it. Okay, so down below, let's set that up. We're going to set up a proportion. We'll notice that we have 2 triangles, a big one and a small one. So let's do big over small. Okay, x. Is x on the big triangle or the small triangle? Well, x is on the big triangle, so let's fill that in up top. What side on the small triangle matches with x? That would be this hypotenuse. And how long is it? It is only 10 long, so x over 10. Okay, we've got half of our proportion set up, but we need another pair of numbers. What's another pair that go together? And hopefully you see that the bases of these 2 triangles correspond, the 8 and the 12. So now we just have to think about, would we fill it in as 8 and 12 or 12 and 8? Since we're doing big over small, we're going to have to do 12 and 8. Okay, from here, we're doing the math. So go ahead and go over to your scratch page. X over 10 equals 12 over 8. And work that one out. I'll do the same and we'll compare answers. And I again get 15. It's the same answer as last time. Okay, see what you got. Let's check. We all got 15. Let's head back and see if 15 is an answer. And sure enough, it is. Excellent. One more. Number 3. Triangle ABC is similar to triangle DEF. And again, similar means that we can do a proportion. What is the length of BC in millimeters? Okay, we know what we're going to do first. Let's color that and call it X. And while we're at it, let's color the side that matches with it. What side over here matches with X? It's going to be EF. Okay. Let's color another pair while we're at it. Looks like those bases are going to match the 9 and the 12. Alright, so now all we have to do is set up our proportion. I don't have very much room on that page, so I'm going to kind of just go across the page here a little bit. Or try to, and set up our proportion right here. Okay, we're trying to find X, so we better put X in our proportion. X, zoom out a little bit, over, what does the X, oops, I guess I should have called this time we're doing small over big. And again, you could do it the other way, doesn't matter. We start with X. X over, what does it match with? 16. Okay? Equals, we're doing small, so let's go back to the small one. 9 over, what does it match with? It matches with side of 12. Okay. Once we have our proportion set up, we just need to work it out. Go ahead and work that one out. I'm going to work it out off camera. And I get an answer of X equals 12. If you're not done that math, though, go ahead and pause the video so you can check to make sure that that's correct. Okay, it's a good time for us to practice how would we enter that. Our answer is 12. So our real answer is like 12 point. The point would come right after the 2. So that's how we're going to put it in. 1, 2, right in front of the decimal point, and just fill in those 2 numbers. And we're all set.
All right, there's one other thing that I'd like to look at before we do some practice. So if you'll go ahead and turn to a blank page in your book, preferably in that same section, I want you to write down these 2 examples. So go ahead and start writing down example 1. You may need to pause the video so that you can write it all down first, and then unpause the video so we can work through it together. Okay, here we go. Example 1. Triangle ABC is dilated to form triangle A prime, B prime, C prime. These little tick marks are called primes. Determine the scale factor, and is this an enlargement or a reduction? The first thing we need to do is figure out which one is new and which one is old, because that will help us figure out the scale factor. So it says triangle ABC is dilated to form, to make a new one. So that means that triangle ABC is the old one, and triangle A prime, B prime, C prime is the new one. Okay? And that's the first thing we need to do. So down here we could label this as well. The big triangle is new, and that little triangle is the old one. This is what we started with, and then we dilated it and it became this new one. Okay, so let's do part A, scale factor. Scale factor is equal to new over old. Okay, so in this case, we're just going to pick a side on the new triangle. So we got to pick 6 or 4.5. Well, looking at that, we're like, well, 6 is probably a little bit better because it doesn't have a decimal in it. So let's use the 6. So 6 over. Okay, now we need the side that matches with 6 because we always have to do matching or corresponding sides. So I colored this yellow. What side on the old triangle matches with this side on the new triangle? Well, that would be side AB, which has height 4. So it'd be 6 over 4. Okay, we can reduce that a little bit, and we'll get that the scale factor equals 3 over 2, or 1.5. Okay? So now we have to answer the second question. We figured out the scale factor. Is this an enlargement or a reduction? Well, think about what those words mean. Enlargement, did our shape get bigger? Or reduction, did our original shape get smaller? Well, if this was our old shape, and then this is our new one, we got bigger. So this is an enlargement. Excellent. Let's try one more. Example 2. Again, I'd like you to start by pausing the video and copying out the question just as you see it on the screen. Then unpause the video and we'll work through it together. ABCD is a dilation of MNOP. Determine the scale factor. Is this an enlargement or reduction? Okay, ABC is a dilation of MNOP. So this is our new one. This is what we made. Okay, so ABCD is our new, and MNOP is our old. Okay, so let's label that down here. This is our new shape. This is our old shape. Okay, we need to do the same thing. We need to find our scale factor, and we also need to figure out if it's an enlargement or reduction. Let's start with scale factor. We know scale factor equals new over old. So we go to our new shape, which is the smaller one. And our only side we have is 12, so we're going to have to use that 12. I'm going to go ahead and highlight it. Now, I made this one up to be a little bit tricky. 12 over what? What side on this on the old rectangle matches with that? And you might be tempted to say 8, but it's not. It's going to be 20. Why? See how this is the length or the longer side of the rectangle? It has to match with the length or the longer side of the other rectangle. And so it doesn't matter that it's turned sideways, we still need to use the length. So it'll be 12 over 20. Let's reduce that a little bit. Both those are divisible by 4, so we'd have 3/5 is our scale factor. Excellent. Let's try part B. So if this was our old shape, and then we dilated it to create this one, is this going to be an enlargement or a reduction? Well, since we got smaller, this is going to be a reduction. And that's how to find scale factor and determine whether a dilation represents an enlargement, something that got bigger, or a reduction, something that got smaller.
Okay, let's talk about the next questions I want you to do. I want you to do number 4 at the bottom of this page. And then I want you to flip the page over to page 101. And you'll see 4 questions there. I want you to do all those 4. And then you'll flip the page over to 102. And I want you to do those 4 as well. Mr. Wyatt, or the teacher that's with you, does have the answer key, so you'll want to check and make sure that all of your answers are correct. Great work.